This is just a quick video to talk about tackling these K questions that have to do with our discriminant that a lot of people have a little bit of a hard time with. So we've talked about discriminants. We know the equation of the discriminant is b squared. Discriminant is equal to b squared minus 4ac. What throws people off are these questions with k, and k is just another unknown. So we don't know the value of k, but we can say that certain values of k are going to give us a parabola that has two distinct real roots. So in other words, cuts the x-axis in two separate places. We could find values of k that are going to give us a parabola that have a repeated root. So in other words, come down or up and touch the axis in just one spot. And then no real roots. So in other words, they're never cutting the x-axis. It's either floating above or perhaps even floating below the x-axis and opening downwards. So we're able to decide or to determine what values of k would make all of these situations true. So the first thing that we need to do is find the discriminant of this function. And we know that the discriminant, delta, is equal to b squared minus 4ac. So in this case, our b value, or in every case, our b value is always the coefficient of our x term, so the term that has x in it. So in this case, our b value is k plus 3 squared. Subtract 4 multiplied by our a value, which is always the coefficient of x squared. So in this case, just k. And our c value. And we need to remember that this equation really needs to be in standard form in order for us to find a, b, and c. So standard form equations are always equal to 0. So we actually need to move this 1 over to the other side and set this equation equal to 0 in order to find out what c is. So now we've got kx squared plus k plus 3 onto x, subtract 1 equals 0. And we know our c is always our constant term, or the term that doesn't change, so our c value is negative 1 here. So just simplifying this out a little bit, we've got k plus 3 to the power of 2. So this is a binomial expansion. And when we expand that out by FOILing, we're going to get k squared plus 6k plus 9. That's all part of this k plus 3 squared. On this end of the problem, we've got negative 4 multiplied by k multiplied by negative 1, which is going to give us positive 4k. We can then combine our like terms just to make this even more simple. So we've got k squared plus 10k plus 9. So we've found our discriminant. This is the discriminant, k squared plus 10k plus 9. So at this point, we need to find the value of k, or assign some values for k that are going to give us two distinct real roots, a repeated root, or no real roots when we graph this original equation. So the first thing that we want to do is set that discriminant equal to 0. And that's going to let us solve for values of k that would give us a repeated root. Because when you remember, when we talk about discriminant, if the discriminant is equal to 0, we're going to have a repeated root. If the discriminant is a positive number, in other words greater than 0, we'll have two distinct real roots. And if the discriminant is a negative number, we're going to have no real roots. So by solving and setting the equation equal to 0 and solving for k, we're going to find the values for which we're going to have a repeated root. So we would solve this just the way we would solve any other quadratic, which is trying product sum first. So in this case, we're looking for two numbers that are going to multiply to give me positive 9. And those same two numbers have to add to give me 10. And it becomes pretty obvious that those numbers are going to be 9 and 1. So I'm going to factor this into k plus 9 onto k plus 1. So my solutions here are k equals negative 9 or k equals negative 1. So if I took negative 9 and plug it in for k up here in our original equation, and then graphed it, I would find a graph that has a repeated root. Same thing for if I take k equals negative 1 and plug it in up here, I'm going to have a graph that has a repeated root. So it's going to come down and touch the axis in one spot. because when k is negative 9 or k is negative 1, we know our discriminant is equal to 0. At this point, we need to take a look at what values of k would give us two distinct real roots and what values of k would give us no real roots. And in order to do that, we have to draw something called a sign diagram. So a sign diagram is essentially just a number line. And on that number line, we place the values that we found when we set our discriminant equal to 0. So we've got negative 9 and negative 1. From here, we need to test some points. So we need to test a point that's greater than negative 1 to find out what the sign is going to be over here. So I'm going to pick 0. I'm going to test 0. So if I test 0, I've got, using this equation here, 0 plus 9 onto 0 plus 1. And we're not interested in the actual result of this. We just want to know if the answer is going to be positive or negative. Over here, I've got a positive number multiplied by another positive number, so I know my answer is going to be positive. So what this tells me is that for all values of k greater than negative 1, I will have a positive answer for my discriminant. So in other words, for all values of k greater than negative 1, I'm going to have two distinct real roots. We now need to test a number between negative 1 and negative 9. So I'll pick negative 3. So negative 3 plus 9, that's a positive number. Negative 3 plus 1 is a negative number. Negative multiplied by a positive would give me a negative result. So for all values of k between negative 1 and negative 9, we're going to have a negative discriminant. So in other words, we'll have no real roots. Now I need to pick a number that's smaller than negative 9. I'll pick negative 10. So I've got negative 10 plus 9. That's negative. And then I've got negative 10 plus 1. Also negative. Negative multiplied by a negative gives me a positive result. So for all values of k less than negative 9, I'm going to have two distinct real roots. So just to sum up our answers, our answer for A, two distinct real roots, would be that k is greater than negative 1 or k is less than negative 9. Our answer for B, repeated root, is that k is going to equal negative 9 or negative 1. And our answer for C, no real roots, is that k will be between negative 9 and negative 1.